The first skill from section 2.6 is just being able to identify positive, negative, and no correlation. And what this means is a lot of data is taken from an experiment or an observation, and they're plotted on a graph like this, like you see below. And you just need to determine whether there's a positive correlation, so as this increases, this also increases. A negative correlation, as this increases, this decreases. It's negative because it's losing value. Or no correlation, there's no relationship between what's being measured here and what's being output here. Something that you can see is that if there's a positive correlation or a negative correlation, you can draw a line of best fit through the data points, like here. This is a line which has the equation of a line, and a negative correlation does the same. So these lines will have some format, y equals mx plus b, and that's what we need to find. Okay, I want to walk you through an example of the next skill you need, and that is to approximate a best fitting line. And I chose this example from the textbook because I think it very clearly shows what you're supposed to do, and we can just follow. You can just walk with me through this. So it says alternative fueled vehicles. The table shows the number y in thousands of alternative fueled vehicles in use in the United States X years after 1997. Approximate the best fitting line for the data. So it gives us all these plot points. First step is to draw a scatter plot of data. So they put a dot at 0, 280, 1, 295. Like you can see, it's all plotted on the graph right here. The next thing says sketch a line that appears to best fit the data. And all I did was try to draw a line as best as possible to fit through all these points. Of course, it doesn't touch them all, but it gets close. So that's step 1. Step 2. Step 3. In order to approximate the equation of this line, the first thing we need to do is determine the slope of this line. Now we're going to choose 2 points that appear to lie on the line. For the line shown, you may choose 1, 300, which is not an original data point. It's just this black dot here, but it's on the line, so right here. And 7, 548, which is an original data point. All you need to do is choose 2 points, as long as they're on that line of best fit. It doesn't matter if they're original points or not. So once you choose those 2 points, you can find the slope through that equation we talked about, y2 minus y1 over x2 minus x1, which they did here, to get 41.3, which is the slope of this line. Then, once they have the slope, of course we learned before, if you have 2 points, you first find the slope to get m. Then you use point slope form to write the equation. So using y minus y1 equals m times x minus x1, and they walk you through it right over here. Substituting one of the points they chose, that's on the line. They just used one of the points that they used to find the slope from. Then they simplified and said an approximation of the best fitting line is this. This is the equation of the best fitting line for this